Good morning. Sorry, I'm a little late, apparently. Okay. Bum, bum, bum. I'll wait a little longer. There's only 11 people. Like all the other times, it will be recorded. So that should be helpful. On the humongous review sheet, the only part we haven't really gone over yet is Unit 7, so we'll go over that. And if you have specific questions from the free response questions, I will answer those. Otherwise, I have ones that I'm planning on going over. Okay, well, let's get started. Interestingly, it seems like we have less people at these Zoom meetings each time. Hopefully, those of you taking the AB exam, which is the vast majority of you, are doing something to prepare. If you are not joining in on these. Okay, so I'm going to share my screen. Don't want to share that. Let's go to this. Okay, so same information I gave you last time on Friday. If you need any more information about what it will look like, apcoronavirusupdates.collegebboard.org has a lot of information about this year's exams and the changes to this year's exams, as well as that's another place with the link to the YouTube live review videos. Also, this very soon, they're going to be coming out with tutorial videos on like how to use their website for the exam. They're going to come up with, I think they may also be like doing like a trial version for you to be able to go on and practice doing the upload, that kind of thing. So watch for those emails. You should also really be getting emails from College Board. So again, the exam is May 12th at 1. If that's now less than 3 weeks away, so 3 weeks from yesterday. Again, 45 minutes, 3 response questions, just 2 questions. First question, 25 minutes with 5-minute upload. It's worth 60% of the exam. It is essentially open note, open book, calculated aloud, but not required because of the scenario that we are in. You could take a pic. You could use computer, tablet, or phone. You could take a picture of your work and upload, like some of you have been doing for our assignments. All of that works. In this week's free response questions for the assignment, you had to do the 2016 free response questions, but not number 5. And then the file labeled AB 1 through 4 free response question number 2020. The first 2 in that file are in this format, where the first question is worth 60%, second question worth 40%. The first 2 questions in that file were meant to be what the person who made those, what Brian Passwater, thought this year's exam could look like. So the first 2 in that are a great representation of what this year's exam might be like. Okay, let's go to the humongous review sheet. What is a differential equation? So this is the unit we did right before spring break. Differential equation is really any sort of equation involving a function and its derivatives. Any equation involving a function and its derivatives. So it will usually look like will give you f prime of x or equals something, or they will give you y prime equals something, or they will give you dy dx equals something, something like that. What a differential equation is. A slope field, not really enough room right here to show what one is or how to solve one. We're going to do one today in the free response question I'm going to do. But I'll write a few things here of like what you need to be able to do with slope fields. With slope fields, you need to be able to draw a slope field. Got to be able to draw a solution curve. Or given a slope field, be able to identify differential equation. That's what DEQ stands for, differential equation. or possible solution equation. So, I mean, and we learned how to do all of those things when we did slope fields before. Okay, number 3, Euler's method. Y'all don't worry about that. 4, what's a separable differential equation and how to solve it? Well, a separable differential equation is one where we have dy dx equals g of x f of y, meaning anything dealing with x, anything dealing with y can be separated so that you could then separate things onto their appropriate sides of the equation, making it separable. So if we have a separable differential equation of this form, our first step is to separate the variables. First step is to separate variables. What did I just draw? We're gonna, here we go. Try and draw a 1 for first step. First step, separate variables. Second step, integrate. And so if we do that first step here, we've got to move the f of y over to the left side, because with the dy dx, the top variable is always going to stay where it is. I mean, they could give you dk dt or some other kind of relationship, but the top dependent variable stays where it is. So moving the f of y to the other side, it would then end up being 1 over f of y dy equals g of x dx. Then the second step is to integrate. And then when we integrate this, you also will need to end up with a plus c. If it is not a particular solution kind of problem, if they don't give you an initial condition, plus c will still be in your answer. So next you would then step 3, solve for y. So if they don't give an initial condition, it's not a particular solution kind of problem, you would then immediately solve for y. You'd then immediately solve for y. But number 5 asks, describe how to use an initial condition to find a particular solution. In that case, the easiest way to do those is you would plug your initial condition in, plug in initial condition, right after integrating. To find C. And then once you know what C is, then you'd plug it back into the equation you had right after integrating. And we'll do kind of an example of that with number 6. Number 6, we're asked write an exponential differential equation and what its solution is. So the most basic exponential differential equation that we saw over and over was dp dt So that was our differential equation. First up, we then separated variables. So we moved the p over the other side to get 1 over p dp equals, we move the dt over to the other side, k dt, and then we integrated. When we integrate the 1 over p, you get natural log of absolute value of p. Integrate k with respect to t, you get kt plus c. Then we want to get p by itself, so we'll e both sides to give p equals c e to the k t. But c is essentially just the initial condition, so we can call it p equals p sub 0 e to the k t power. This is an e. There we go. Okay. And that's pretty much it for your humongous review sheet. You should have it, if not all done, almost all done. At the very least, every piece that I did during these. Y'all do not have to worry about Unit 8 this year, which is, I don't know, good or bad. I mean, it's not usually in Cal 1, depending on the school anyways. Okay, so then based on that, no, not that. We're now going to go to 2016 question 4. So on Friday, we did 2016 question 3. Since today's review stuff was on Unit 7, differential equations, I thought it would be fitting to actually do a free response question going over differential equations. 2016 question 4 does exactly that. So this is from this week's assignments of free response questions, 2016 question 4. We are asked, consider the differential equation dy dx equals y squared over x minus 1. And first thing we are asked to do is sketch slope field given that differential equation at these 6 dots they have. Well, first question that I got for you, why don't they have any dots under x equals 1?
Does not exist.
Yeah, it would not exist. When x equals 1, this differential equation would not exist. We would end up with 0 in the denominator, so the slope would not exist. So nothing's even happening there. It's possible a vertical tangent, but possibly an asymptote. We don't really know yet, but it wouldn't exist, so there's no point in having us put one there. Okay, so we're going to fill in this slope field. Well, when y is 0, what will our slope be?
Negative.
Negative. Let's look at this. If we plugged in 0, 0, we would end up with 0 over negative 1, which would be 0. If we plugged in 0, 2, we would end up with 0 over positive 1. Both of those are just 0. It doesn't matter having the negative on bottom. If you have 0 over a number, that's 0. So when y is 0, we want to draw a slope that looks like a horizontal line. Okay. At 0, at 0, 1. At 0, 1, this point right there, we would end up with 1 squared over -1. Well, that's just -1. So we want to have a -1 slope. Then at 2, 1, we would have 1 squared over 2 minus 1, which would be a positive 1 slope. At 0, 2, we would end up with 2 squared over -1. So that would be -4. So I want to have a way more steep one. And then same thing's going to happen, but opposite on the other one. We would end up with 2 squared over 2 minus 1. 2 minus 1 is just 1. So that's 4 over 1. So it's a very steep positive. And show you point values. They would have given you 1 point for having your 0 slopes right, and then 1 point for all the other slopes. Then letter B. Letter B says let y equals f of x be a particular solution such that the differential equation has the initial condition f of 2 equals 3. We're asked to write an equation of a tangent line to the graph, and then use that tangent line to approximate f of 2.1. Well, we need to remember our tangent line approximation. It's going to be y equals. I'm going to move the f of a to the other side. I'm moving it to the right side because we're going to plug stuff in anyways. F of a plus f prime of a times x minus a. So that is our tangent line equation. They gave us the initial condition f of 2 equals 3. So that right there, that is our a f of a, where the 2 is the a, and then 3 is then the f of a. The tangent line equation, the y value at the point plus the slope at the point times x minus the x value at the point. So let's find f prime of a. Well, f prime of a, I'll do that up. Y squared over x minus 1. Okay. So we want dy dx at the point 2, 3. And the differential equation is y squared, right? Y squared over x minus 1. So that would end up being 3 squared over 2 minus 1. So that is 9. So writing our equation, we get y equals 3 plus 9 times x minus 2. There we go. That's the equation. And the equation, you're aware, was worth 1 point. And then now we're going to plug in f of 2.1 because we are asked to approximate f of 2.1. So we're going to have y equals 3 plus 9 times 2.1 minus 2. And we want to solve that now. Well, 2.1 minus 2, that's just 0.1 times 9 plus 3. 0.1 times 9 would be 0.9. 0.9 plus 3, that is 3.9. And that was worth 1 point. But on this problem, since you don't have to simplify, you could have stopped when you plugged in the 2.1. That would have been fine. If you don't trust your own math, you could stop as soon as you have a bunch of numbers together. Okay, and let's go into part C now. Part C. Part C, same difference equation. Now we're asked to find the particular solution. Find the particular solution. So as already discussed earlier, first step in finding a particular solution is to put this back down there. First step in finding a particular solution is to separate the variables. Separate the variables. So when we separate these variables, we're going to move y squared over to the left because the y is going to be on the left side, and dx over to the right. So we will end up with 1 over y squared dy equals 1 over x minus 1 dx. Second step is to integrate. This step has to be shown. Separating variables has to be shown. You can do like I'm doing and separate the variables and then immediately integrate. That's perfectly fine. But it has to be shown that the variables are separated before you go on to integrating. So now we're going to integrate. Integral of 1 over y squared. Well, 1 over y squared, that is really y to the negative 2 power. We're just doing reverse power rule here. So the power is going to go up 1 to negative 1, and we multiply by the reciprocal of the new power, meaning we're going to have that's going to become y to the negative 1 divided by negative 1, meaning negative 1 over y. And that will equal, well, integral of 1 over x minus 1. If we just treat x minus 1 as one whole unit, this is going to end up being natural log the absolute value of x minus 1 plus c. Can't forget your plus c. Can't forget your plus c. We already saw that part A was 2 points and part B was 2 points. So then this part C must therefore be 9 points, since in all previous years, free response questions are worth 9 points. So this whole part is worth 9 points. If you don't have the plus C, you only have a maximum of 3 points on this problem out of the 5. And now, as I said earlier, now is the best time to plug in our initial condition. We're going to now plug in our initial condition of f of 2 equals 3. F of 2 equals 3. So plugging that in, 3 is going to go in for y, so we have negative 1 third equals natural log of 2 minus 1 plus c. Well, 2 minus 1 is 1, so this whole thing is natural log of 1. What is natural log of 1?
Zero.
It is 0, yes. Natural log, that whole thing is going to be 0. So that therefore tells us that c equals negative 1 third. Now that we know this c is negative 1 third, we will now plug it back into that c right there and write our new equation and get y by itself. What color should I go to now? Change colors for each step. Okay, so now we have negative 1 over y, so weird brown, equals natural log of x minus 1 minus 1 third. And we want to get y by itself, so we can flip all the negatives, make that become positive. That'll be negative in front of the natural log, and now that will be positive. And if we multiply, raise everything to the negative 1 power, then that's just flipping everything, taking the reciprocal, y will equal 1 over negative natural log of x minus 1 plus third. Okay. Now, to address the absolute value sign, back at this spot right here, if we were to plug 2 in, yeah, it wouldn't matter. It's the only point we know. I'll check real quick what they said about that. Oh, because it gave a positive number. It'll still be positive. Let's go back to that. So, since our function is outputting a positive, then this is also must therefore be outputting a positive. So we can drop the absolute value since we already know that that is positive. And so they have it as 1 over. We can switch those. We don't have a negative in front. 1/3 minus natural log of x minus 1. And there we go. That was all question 4 on the 2016 exam. And the purple step was worth 1 point, separating the variables. Red step, integrating, was worth 2 points. Getting C, getting the initial condition and dealing with it, worth 1 point, and the final answer worth 1 point. Okay. We could go over one of the one of the other FRQs from the other file, unless you have specific questions. Does anyone have a specific question people are asking that you want to see? Otherwise, we will
Could you go over 2 on the 2016 free response questions? Question B on number 2.
Question B on number 2. We can do that. Okay. Okay. So share my screen. Okay, question B on number 2. For us to find all times t in the interval from 0 to 3 where the particle changes direction. Find all times where the particle changes direction. Let me do something real quick so I can write on that. Okay, there we go. So we want to find where it changes direction. Not. Okay, where it changes direction, that will be when the velocity equals 0. That will be when the velocity equals 0. Well, they gave us the velocity equation. It's going to change direction when the velocity equals 0. So we just need to figure out when does v of t equal 0 between 0 and 3. Figure out when v of t equals 0 between 0 and 3. And questions 1 and 2 on the 2016 exam were calculator, like allowed, and this is one scenario where it would definitely be necessary. You can't figure out when. I mean, I guess it's, you may be able to. That would then give us that 1 plus 2 sine of t squared over 2. That equals 0. So you'd subtract 1 divided by 2. So you have -1/2 equals sine of t squared over 2.
Hey, Mr. Hunter.
Yeah.
Stephanie said she wanted to go over C, but can you do B as well and then do C?
Oh, but this question number 2?
Yes.
Okay.
Thank you.
So you then want to figure out when sine of t squared over 2 equals -1/2. Well, when does sine equal -1/2? Between 0 and 3. Yeah, you just use calculator for that. Since calculator's allowed, no reason to do something like that in your head. So you just figure out when that function equals 0, and that's where it would be. Just make sure and justify. And the only justification really necessary is that that's because that's the time would be 1 point. What that time is, then the justification is that that's when velocity equals 0. The justification is that that's where the velocity equals 0. Okay, but you really want to see, we can do that. Move that back over there. Okay, on C. C, we're asked to find the position of the particle at time 0. We want the position of the particle at time 0. Well, up here, we were told that the position of the particle is 2 at time 4. It's 2 at time 4, such that we could say x of 4 equals 2. So that's some point, and that's helpful. And based on definite integration and fundamental theorem of calculus, the integral from A to B of velocity dt would equal, well, the integral of velocity is position. Integral of velocity is position, so that would mean x of B minus x of A. Because the antiderivative at the upper endpoint minus the antiderivative at the lower endpoint. So since we know this point, we can say the integral from, we want now to know the position at time 0. So the integral from 0 to 4 of velocity would equal the position at time 4 minus the position at time 0, which is what we want. So I'll just get that get x of 0 by itself. And if to get x of 0 by itself, that could then look like, fix that. Whoa, did that erase everything? Well, that's annoying. I don't know what happened. Well, I guess I'll rewrite that. Part C. Well, to get x of 0 by itself, it would end up looking like x of 4 minus the integral from 0 to 4 of velocity dt. Because we had the integral from 0 to 4 of velocity equals x of 4 minus x of 0. So just adding x of 0 over to the left side, then subtracting the integral, we get this right here. Well, x of 4, they told us, is 2. Then minus the integral from 0 to 4 of v of t dt. This integral, well, you would now just plug that into the calculator. Integral from 0 to 4 of your velocity equation, just plug that into the calculator. How do you do integration in your calculator if you have a calculator?
Math 9.
It would be Math 9, yes. And speaking of that, that probably begs the question from some of you, wait, what if I don't have a calculator that needs integration? Well, something like that, where a calculator is absolutely required, is not going to be on the exam this year. Calculator is allowed this year because there's no way to stop you from using it if you have one. But it's not absolutely required because not everyone has one, or at least not everyone has one that can do that. So that kind of thing won't be necessary to be able to do. So don't worry about something like that if you don't have your own personal calculator. But I will let you know, you should look it up. I'll try to find the link again, but TI has made their emulator software free for 3 months because of this situation for everybody. So you can download the TI-84 onto your computer for free right now. If you just search the TI-84 software, that so if you want me to post that link, I will, but you should all be able to download the TI-84 software onto your computers right now, because TI is making it free for 3 months for everybody. Okay. Any other questions? Any other questions?
Mine's not really about a specific problem, but what all do we have to turn in this week?
You should have done, those of you taking the AP exam, you should be wanting to do every single free response question that I send out for practice. If you're not taking it, do something to show that you're working for class. But just turn in your work just take pictures of your work. I moved the due date to Sunday, as I said. I was quite surprised on late Friday night when I saw people working super late and turning stuff in super late. Again, there's no late penalty in this time. If you get to Sunday and you're not quite done with something, either turn in what you have or just wait till the next day to turn it in. That's perfectly fine. But just turn in your work from the 2016 FRQs and the other FRQs to show you that you did it. The keys are both already posted. I posted those yesterday. Well, with that in mind, we got a little more time. Let's go over something else as well then. Let's look at the other FRQs number in, let's see. So the AB1, it's the second one. This is from page 4 in the other file. Page 4 in the file on AB 1 to 4 FRQ 2020. From that file, from the file AB 1 through 4 FRQ 2020, this is the page 4 one. It's the second one labeled AB1. And we'll go over some of these. Okay. So part A is, well, we have a lot of different things going on in this problem, which is definitely possible. We've got a piecewise, we have a function that is a integration function, we got a graph. Part A is asking us to show that h of x is continuous at x equals -1. Okay, that shouldn't be too bad. We got a piecewise function, we want to show that it's continuous. Well, for it to be continuous, the limit from the left-hand side needs to equal the limit from the right-hand side and needs to equal the actual function. So the limit as x approaches -1. Well, on the left of h of x will equal, well, that would just mean we would plug in -1 into the left-hand portion, the part on the left side of -1. So that would be -1 squared plus 3 times -1 minus 2. And -1 squared, that's a +1. So 1 minus 3 would be -2. -2 minus 2 is -4. So that is the limit on the left. And then, well, h of -1 does equal the limit as x approaches -1 on the right of h of x. And let's figure out what that is. Well, that would then be g of -1. So we got to figure out what g of -1 is. Okay, well, g of -1, they gave us this equation for g. G of -1 would then equal the integral from 2 to -1 of f of x dx. Well, I guess I should have had t's there. I'm going to put t back in so that makes more, so it's more consistent. F of t dt. Okay, well, that's kind of going backwards. That's going towards -1 from 2. So let's flip that. Put a negative in front. From -1 to 2 of f of t dt. Okay, well, now we have integral from -1 to 2 of f of t. Well, up here is our f function. From -1 to 2, they told us it is 4. They told us that's 4. So that integral from -1 to 2 of f of t is 4, and we got that negative in front, so it is -4. Okay, so it must be continuous. Therefore, h of x is continuous at x equals -1. go. Okay, awesome. Part B, we're asked to order the values h double prime of -2, h double prime of +2, and h double prime of 10 from the smallest to largest, and explain our reasoning. Well, that is a lot of stuff there. H double prime of 2. Well, in order to find h double prime, we need to first find h prime. So let's get that first. H prime of x. Okay, we'll just take the derivative of each piece. So that will be 2x plus 3. For x less than -1. And then that will be g prime of x. And then h double prime of x. Well, derivative of 2x plus 3 is 2. Derivative of g prime would then be g double prime of x. Okay, well, one thing that we should know that will be very helpful, it would be a point just writing it on its own. What is g prime of x? If we take the derivative of this area function, integral from 2 to x of f of t, what will we get? What is the derivative of g prime of x? What is g prime?
F of t.
Yes, f of t. Well, we can put the x in there, so f of x. Which would then also mean that g double prime of x is equal to f prime of x, which is kind of helpful. And once you know those things, you should be able to finish that problem. Because then that means if we want h double prime of -2, h double prime of negative, I should have written this stuff. This is for x less than -1.
From
This is for x greater than -1. Right, yeah. So h double prime of -2, well, when x is -2, that's less than -1, so it's just going to be that 2. So h double prime of -2 is just the whole number 2. H double prime of +2, that is just going to be h double prime of +2. That's going to equal g double prime of 2, which equals f prime of 2. Well, f prime of 2, we don't know its actual value, but looking at the graph, it's this slope, which is negative. So that's something we know about it. That should at least help us be able to write the order from smallest to largest. And then h double prime of 10, that is going to be g double prime of 10, which is f prime of 10. Well, f prime of 10, well, the slope when x is 10, that's a horizontal tangent. So that is 0. Awesome. So you can then put the order. I've ran out of space. But h double prime of -2 is +2. H double prime of +2 is negative, and h double prime of 10 is 0. So the smallest one is definitely the negative h double prime of 2. H double prime of 10, which equals 0, is in the middle, and h double prime of -2, which equals 2, is therefore the biggest. Okay, and last part I'll do before we end today is part C of this problem. We're asked to evaluate the limit as x approaches c of g of x plus 3e to the 12 minus 2x all over x squared minus 36. Or state that it doesn't exist. Okay, well, let's figure out the top and bottom on this. If we were to plug 6 into the top, that would be g of 6 see, if I write it like this, limit as x approaches 6, let's just look at the top of g of x plus 3e to the 12 minus 2x. Okay, well, when we plug 6 into this, that would be g of 6. Well, what is, actually, we'll get that in just a second. That would be g of 6 plus 3e to the, well, 12 minus 2 times 6, that would end up being 0. E to the 0 is 1, so that's just 3 right there. G of 6 would mean integral from 2 to 6 of f of t dt. Well, we were told up here, section from 2 to 6, the area would be 3. Or looking at the picture, it's a little more clear. From 2 to 6, the integral is 3, but it is below the x-axis, so it is negative. So this right here is negative 3 plus 3, so 0. So the limit on the top is 0. Limit as x approaches 6. Let's look at the bottom of x squared minus 36. Well, don't have to do anything fancy. That's clearly also 0. So we showed the limit on the top is 0, limit on the bottom 0. So we've got to do L'Hopital's rule. So then by L'Hopital's rule, that whole thing will equal, how do I want to write it? Oh, look, just rewrite it. Limit as x approaches 6 of g of x plus 3e to the 12 minus 2x all over x squared minus 36 by L'Hopital's rule would have to equal the limit as x approaches 6 of, we're going to take the derivative of the top and the derivative of the bottom. So that would mean g prime of x. Then the derivative of 3e to the 12 minus 2x, well, that's going to be itself, but got to multiply by the derivative of the power because it's a chain rule. So then that will be minus 6e to the 12 minus 2x. And the bottom's derivative is just 2x. Okay. And then when we take that limit, I'm going to plug 6 in. I'm going to move that down there. And that will equal g prime of 6 minus 6 all over 12. Well, let's look, what is g prime of 6? G prime of 6, well, we already said earlier, g prime of x is f of x. So then that's really f of 6. Well, based on the graph up above, f of 6 is 0. F of 6 is 0. So then that right there is 0 because it equals f of 6. I mean f prime of, yeah, f of 6. So this is then just a negative 1 f. Okay. There we go. And it has now, it's been a while now, 12:06. So I'll answer more questions from this week's FRQs this Friday. Something I thought would be cool to do this Friday, You might need both a computer and a phone. You'll probably need both a computer and a phone for this, but we'll do a Kahoot through Zoom this Friday. So we'll start off Friday's class because we have no more of the review sheet to go over. We'll start off Friday's class with a Kahoot. You'll probably need both your computer and a phone if that's possible, but thought that'd be a good thing to do some review and then go over more of these FRQs. And I will post next week's assignments today. Obviously, you're not going to start it this early. That'd be kind of crazy unless you're already done. But it'll go ahead and be posted. Again, guys, I miss you, and this sucks. Have a great day.